This video will talk about motion equations when objects are projected up. The variables for motion equations consist of final velocity, which is represented by a v and a vector symbol, initial velocity, which is represented by a v naught symbol and the vector symbol, acceleration, which is shown with a lowercase a and a vector symbol, displacement, which is shown with a delta symbol, followed by an x with the vector symbol, and lastly time, which is represented by t. The equations for motion equations consist of constant velocity, which says that the displacement, or change in x, is equal to the final velocity multiplied by time. This equation doesn't come up when objects are projected upwards, but it is good to know. Constant acceleration equations consist of three different equations. The first one says that the final velocity is equal to the initial velocity plus the quantity of the acceleration multiplied by the time. The next equation says that the displacement, or change of x, is equal to half of the sums of the initial and final velocities multiplied by the time. Finally, we have the change in x, or displacement, equals the initial velocity multiplied by time plus half of the acceleration multiplied by time squared. Let's do an example problem. A child throws a ball straight up in the air, and it reaches the peak of its motion in exactly 2 seconds. What is the initial velocity? How high did it travel? What's the velocity after 3 seconds? What's the height after 3 seconds? These are the questions that we need to explore. First, I'd like to make a table. The table consists of the initial velocity, the final velocity, the acceleration, the displacement, and the time. We are given three facts in this problem. We know that the acceleration is -10 because the acceleration is equal to gravity, and in this problem, positive values are known to be in the upward direction, and negative values are in the negative direction. Since gravity points towards the Earth, it's in the negative direction. We know the time is 2 seconds, and we know that the final velocity is 0 because we're talking about a ball reaching its peak, and when a ball reaches its peak, it has 0 velocity. So what's the initial velocity? For this question, we're going to use the equation that says that the final velocity equals the initial velocity plus the quantity of acceleration times time. We can plug in our numbers and get 0 equals the initial velocity plus the quantity of -10 times 2. We continue to simplify this, and we get that 0 equals the initial velocity plus -20, and this simplifies to the initial velocity equaling 20 meters per second. How high did it travel? We can use one of the displacement equations of the two that we talked about earlier to solve this question. We can say that the change of x is equal to half of the sums of the initial and final velocities multiplied by time. Once we plug in our numbers, we get that the change of x is half of the quantity of 20 plus 0 multiplied by 2. The simplified is the change of x equals 10 times 2, which says that the displacement is 20 meters. Now it's time to solve for the velocity after 3 seconds. So we know that the initial velocity is 20. So for this question, we're going to use the equation that says v equals vo plus at. Since we found the initial velocity in the first part of this question, it is helpful to plug into this equation. We can plug in all the values that we know to find the final velocity, which is after 3 seconds. Once we plug in our numbers, we get that the final velocity is equal to 20 plus the quantity of -10 times 3. This simplifies to 20 minus 30, and we get our final velocity after 3 seconds to be equal to -10 meters per second. And this solution makes sense because when the ball reaches its peak, which is at 2 seconds, the ball would then have to travel in the downward direction, so it would make sense that the velocity would be negative. How high is the ball after 3 seconds? We can use one of the displacement equations to solve this one. Again, we'll use the equation that says that the change in x is half of the sums of the initial and final velocities multiplied by time. We plug in our numbers and we get that the change of x is half of the quantity of 20 minus 10 multiplied by 3. This simplified is 5 times 3, and we find that the displacement, or the height of the ball after 3 seconds, is 15 meters. Thanks for watching.